Should I put my burn items to the left or to the right of the core? That's the question currently haunting every Dooley players, and rightly so because it can make a significant difference to win early. I did the calculation to find it out. I'll put a clean formula to sum it up, but I encourage you to follow through even though it may seem barbaric at first sight. You can actually still understand everything with high school math background, and you need to understand the process to slightly adapt the reasoning depending on the idiosyncratic aspects of your run. So let's assume this is the current state of your board with some items I1 up until IN to the left of the core, which I denote by their cooldown, and also some items to the right of the core. These are burn items, obviously, and these can be either burn or non-burn items. What I call the effective cooldown of the core is the amount of times it effectively procs in this setup. It depends on the cooldowns of the items to the left charging it. I made a video to compute this, but for now just take this as granted. That's the effective cooldown of the core in this setup. The quantity we're interested in is the burn per second, which from now on I'm gonna call BPS. And it's very easy to compute for the items to the left of the core. It's just the amount of burn they do individually. This amount could be 0 for non-burn items, obviously. For the core, it is also very easy to compute once you've computed its effective cooldown. It's the amount of burn of the core divided by its effective cooldown. And for the items to the right of the core, now it's a little bit more complicated. Also, I just mentioned right now, there's no omega ray in this setup. It would make the computation much more difficult, but I could maybe make a future video to add it. Anyway, for the items to the right of the core, the amount of burn they deal increases over time because the burn core will increase their burn by 1 every time it procs. So what's happening is from the beginning of the fight to the first proc of the core, the formula is basically the exact same as for the items to the left. Then, after the first proc of the core and up until the second procs, the amount of burn they deal increases by 1. We can rewrite this quantity as the same as before. And here we have 1 divided by the cooldown of the first item up until 1 divided by the cooldown of the last items. So this quantity here is the same as this one. From now on, I'm gonna call that Q. And this quantity, the sum of the inverse of the cooldown, it's actually the same as the alpha we talked about here, except, let's say, to avoid any confusion here, it will be the alpha for the items to the left of the core, and here the alpha to the right. But from now, if there's no confusion, let's just denote this as alpha. Same thing from the second to the third cooldown of the core. Now, the amount of burn of our items to the right has increased by 2. And so, in this time, they deal Q plus 2 alpha burn. This immediately generalizes to that formula for the amount of burn they deal in n times. What we're interested in is the average burn per second these items to the right are gonna deal during the fight. So for now, let's fix n as an estimate of the amount of times you think your burn core is gonna proc. We just sum all these values, and that's an arithmetic series that we have to sum. The result is n times q plus that thing times alpha, which makes a BPS of q plus n minus 1 divided by 2 alpha. So if we go back to the total BPS here, we have found out the value to the right. And actually, let's rewrite this quantity q as q right and here q left, because it's the exact same. And we're going to have to move the items to the right, to the left to see the difference. So this notation will be practical. Now let's imagine a different scenario where all the items that were previously to the right of the core are actually to its left. But they're the exact same items. And let's call this scenario 1. The BPS now would be q left for the items to the left, which are the same. Now, the item previously to the right still have their quantity q right, which was constant over time even in the previous scenario. They don't have this amount, which was depending on the increasing burn that the core gave them. And the core have the same amount of burn, but now it has a different effective cooldown. So let's denote in the scenario 1 effective cooldown of 1 and here effective cooldown of 2. We're getting to the end of it now. To know which scenario is preferable between the scenario 1 and scenario 2, we have to compute the difference in their burn amount per second. So we can see that these two quantities cancel out, and the only remaining part is the constant increase in the first scenario plus here we can put the burn core as a factor, and we have this quantity for the difference. If this quantity is greater than 0, it means scenario 1 is preferable to scenario 2, as there is more burn per second dealt on average. So this is the case if this is greater than this. We can already compute this quantity with the burn effective cooldown calculator that I mentioned in the previous video. And we could already compare it to that if we estimate correctly the amount of time the burn core will proc during the fight. Alpha is also known. It is the sum of the inverse of these cooldowns. So everything here is already computable, but we can actually arrange it much further than that. Sorry, I made a mistake. Here it should be ECD2 and minus ECD1. Because when this goes to the other side of the inequality, there is a minus sign. And we already know ECD1, it's this thing here. ECD2 is actually the same, except now we add the alpha on of the items to the right. I mean the items which were previously to the right on scenario 1 and now to the left on scenario 2, since here it's the same alpha as here. And so we can compute their inverse, which is, so that thing minus that, they will cancel and only leave alpha right, divided by the base cooldown. So the scenario 1 is better than scenario 2 if so this inequality is true, but we've seen that this could be replaceable by that. Now there's alpha right on both sides, they cancel out, so they actually do not even matter, and we end up with this inequality. If we rearrange it a little bit, and let's say we don't take into account this -1, that's what we effectively end up with. However, we don't want to estimate n. We would rather want to estimate the average length of the fight. So we can write n as the total length of the fight divided by the cooldown of the core, since n, if you remember, is the amount of time we expect the core to proc during the fight. This can be rewritten like this, and so n, if we say scenario 1 is better than scenario 2 if n is greater than this, it means that quantity is greater than that one. The base cooldown of the core actually also cancel out, and so we end up with, if the amount of time of the fight is greater than 2 times your burn core divided by 1 plus alpha, then it is better for the items you consider putting on the right to actually put them on the right, no matter if it's 1, 2, or k items. Intuitively, this formula makes a lot of sense. There are basically two factors to take into account. The longer the fight lasts, the better it is to have items to the right of the core. The higher the amount of burn of your core is, the better you want to put items to the left of the core, because here, let's say your burn core has 10,000 burns. Even though it increases the burn of items to the right, you would rather just charge your 10,000 burns on the core. And also, since alpha increases, alpha decreases for items with higher cooldowns, it means 1 divided by 1 plus alpha increases for items with higher cooldowns, and so you would rather put items with higher cooldowns to the right of the core. As a sanity check, we can see if the formula is coherent for the scenario where we only have a lighter, so it's a 3-second cooldown items with 1 burn, and a basic bronze ignition core, which is 6 seconds for 6 burn. The alpha of the lighter is 1 out of 3 because the cooldown of the lighter is 3 seconds. So therefore the formula predicts, so this quantity is 9 seconds. And if the fight lasts longer than 9 seconds, it would be better to have the lighter to the right of the core. And if the fight lasts less than 9 seconds, it is better to have it on the left. So let's see what happens at the breaking point. In scenario 1, which will be core and then lighter, in 9 seconds, the core will proc only once, but it will also be halfway through its second proc. So let's say that's 9 burn for the core. And the lighter, it will have 1 for the first proc, 2 burn after the second proc because the core will have procced it once, and again 2 burn for its last proc. So that's 14 burn. And in scenario 2, which is lighter to the left of the core, the lighter procs 3 times but always at 1 value now, and the core will proc 2 full times because its effective cooldown is 4.5 seconds. You can check in this formula if you don't trust me. And so the core will proc 2 times, so that's 15 burns. That's obviously the breaking point we talked about. Also, I made a minor approximation by replacing a n-1 by just n. So the formula predicts well that t equals 9 seconds is actually the breaking point. And if t is strictly greater than 9 seconds, then it becomes better to have the lighter to the right of the core. But now we are at the limit where it's still better to do this or equal. And anyway, what also matters a lot, but I could not take it into account here, is the synchronization of your burns, because even though you deal more burn on average, maybe it's better to have them all proc at the same time, especially early game, because then you would have 20 burn instantaneously instead of like 10 burn plus 10 burn 3 seconds from now, which would definitely not be the same amount. Finally, if your core is upgraded, or if you've picked the option which makes it give more burn to the items to the right, first, why the fuck do you pick that option? But anyway, if the core at each time it procs gives not 1 but X burns to the items on the right, we just increase the amounts here by multiplying them by X every time, so that would be a factor X here, here as well. And let's not do all the calculation, but at the end you can check that the new threshold becomes t greater than 2 times the burn core divided by x times 1 plus alpha.